What's up, Mindsetters? Welcome to your grade 11 Maths Monday show. I am Looney, and with me is Sihle. How are you, Sihle?
Hi, grand sister.
So what are we doing for the grade 11s today?
We're doing cyclic quads and tangents today.
All right. Mindsetters, I hope you're excited for the lesson. We are not alone today. We have a special guest in studio. Hello, how are you doing?
I'm fine, and you?
I'm good, thanks. So tell us who you are, which school you go to, and why you are here.
I'm Difelani Slaelo, and then I'm from Progress Comprehensive High School.
All right, and you're here to learn maths
Yes, I'm here for
and
maths.
to be a good student,
I am.
a clever student.
I
And
am.
you're going to answer all the questions.
I'm a genius.
Okay, you heard David Mindset. He is a genius, so he's going to answer all your questions. He's not going to do anything today. He's going to answer all your questions. Remember to hit us up on Facebook, on facebook.com/learnextra, and then on Twitter, our handle is @learnextra. And if you want to win yourself this awesome Casio calculator, all you need to do is go to our Facebook page. We do have the Test Yourself link there for the grade 11s. You click on that link. There is a QR code on our link as well. You enter that link, you fill in all your information, you answer all the questions, and you'll stand a chance to win this Casio calculator. Remember, entries do close on Monday at 8 in the morning, so you have all the time in the world to enter this Casio competition, guys, to stand a chance to win this awesome calculator. So remember, congratulations to Mapule Kelezo. You have won yourself this awesome Casio calculator. It's just remembering the name. Mapule Kelezo, you have won yourself this awesome Casio calculator from last week's Taste Yourself grade 11 competition. Sihle?
All right. Thanks, my sister. Looks like we like it today. We've got a friend of ours, Ndife, is going to be answering all your questions today. But we're looking at your cyclic quads, and like our lesson today will be applying the theorems about cyclic quads and tangents to a circle to solving radius. Okay, and on the screen here we have your challenge question, and just reading it to you, we've got two concentric circles centered at O, have a radii of 5 centimeters and 8.5 centimeters respectively. QR equals to 6 centimeters, and OT is perpendicular to PS. You need to find the length of PS. So you guys will be working on that on your challenge question. And just a brief summary on what we'll be looking at today. You've got your cyclic quadrilateral here, and the things that you need to remember with your cyclic quads is that the opposite angles of a cyclic quad are supplementary. So if I've got this plus that, so A plus your C must give us 180 degrees, or your D plus B should give us 180 degrees, okay? And the next one, the exterior angle of a cyclic quad is equal to the interior opposite angle of a cyclic quad, okay? So now you've got, this is your exterior angle, will be equals to your opposite interior angle of a cyclic quad. Okay, so, and now with your tangents, just a reminder, tangent, it's not tandega, it's tangents. So this is a line that touches a curve at one point. Can you see that this is a curve, all right? And you've got a line there, a straight line that touches a curve there at one point. That's the same thing. Okay, so you've got your two tangents there, all right? It's touching the curve only at one point. But now we look at this line ACBD. Okay, it's also a line, but it cuts your circle in 2 points, so C and D. So we call this a secant. Okay, right? And a tangent to a circle is perpendicular to the radius at the point of contact. And if we look at this, this is a radius. So from the center to the circumference. And at the point of contact with the tangent, your radius is perpendicular. So you've got 90 degrees there. Okay, same thing applies here. So you've got your radius as well. Okay, and number two, your two tangents drawn from a circle, drawn to a circle from the same point outside the circle are equal in length. Okay, So they're from the same point H, okay? These two will be equal in length, okay? Right? And then with your tan chord theorem, the angle between a tangent to a circle and the chord drawn to a point of contact is equal to an angle in the alternate segment, okay? So, yeah, so that's about it that you need to remember, okay? Right? And then on your questions for today, looking at our question 1, in the diagram, AB is a diameter, right? You have to remember what a diameter is, okay, of a circle, ABCD, and angle A2 is X, okay? All right? So you've got that, okay, that's question 1. And I'm just checking because today we said Ndife is going to be giving us all the answers, all right? So Ndife, you ready, right?
Yes.
So you're working on the first question.
Yes,
okay,
I'm working.
Fine. You've got a diameter AB, okay? So this is from A, and then there's going to be a center somewhere, and then that's a radius, then those two up to B, that's your diameter. Now, this you need to remember, there's a theorem that we did also last week, that an angle subtended by a diameter is
Equals to 90 degrees.
Thank you very much. So equals to 90. So this is the one that is subtended by your AB. Okay, so C2 will be 90. Now, they're asking us to find the size of D in terms of X. So we're looking for this, Ndife, right? Any
Yes.
idea?
I'm thinking we're going to consider the triangle DCA.
DCA. Okay, we've got the triangle DCA. All right. Okay, now, like what is just said, okay, we've got your AB as your diameter, and we know that the angle subtended by the diameter is right angle, so we've got a 90 there. Now, can you see that those points, the A, D, C, B, it is a cyclic quad. Okay, we
On the
drew
circumference.
a circle around those points, okay? Now, what you need to be reminded of is that opposite angles of a cyclic quad are supplementary, right?
Yes.
So if I add the
Then
D to the B, I have to get 180.
180, yes.
All right, so is it possible for us to get that angle?
Yes,
Okay?
it
Is-
is.
Yes?
Yes, it is possible.
How can I get that angle?
Because we know that A2 equals to X, and we know that C2 equals to 90. And
Yes.
then we have triangle ACB. Then we're going to say B, it equals to 180 minus 90 minus X.
Thank you very much, right there. Luni, yabo yasinathi?
Very clever.
Thank you very much.
Now we have
Aye,
that,
clever boy.
Really
All right, so
clever.
you've got that triangle ACB, okay? So he's saying you've got your B, okay, plus the 90 that we worked, that we know that AB is a diameter and it subtends that angle, plus the X, okay, equals to 180 degrees. So some angles of a triangle, right?
Yes.
Now we can make your B, we can make B the subject. So B will be 180 degrees minus 90. That gives us 90 minus X.
X.
So we have this angle here as 90 degrees minus X. Now we need to get D, all right? So now it is easy now for us because we know that this is a cyclic quad. Opposite angles of a cyclic quad are supplementary. So you've got your D, okay, plus the one that we just worked out, 90 minus X,
Equals
gives
to
us
180.
equals to 180, right?
Yes.
So therefore, D will be equals to what, Ndife?
My D is going to be equals to 90 minus X.
Come again, just double check that. You've got a 90 minus X here on your left.
It's going to be, we're going to take those to the other side. It's
Yeah.
going to be 90 plus
It's
X.
90 plus X. So this is 90 degrees plus X.
X.
So your D is 90 degrees plus X. Okay, so thank you very much, Ndife, on that question. All right, I hope it answers your questions, guys. Right, now we're moving on to question 2. Right, sorry, with question 2, it says O is the center of the circle, okay? So we've got O there as the circle, as the center. And then AE, it's equals to EF, right? Now we need to find where AE is. Okay, so AE
is equal to,
right, will be equals to EF. Okay, so we indicate that by that. Okay, are we together?
yes.
All right. And BAF and CF are straight lines. Okay, and C1 is X. Okay. Now, so they've given us C1. C1 is X. Okay. We need to express the first question. We need to express E1 in terms of X. Now, guys, there is E1 here. How can I get E1 in terms of X?
My idea can be to first find F, angle at F, which is
Okay.
going to be equals to X also. Because
Thank you
tan
very
chord
much.
theorem.
Why is it this angle here equals to that?
Tan chord theorem.
It's tan chord theorem. So we've got this angle is X. Guys, are you all watching? You've got a tangent, okay? Right. So BC, let's just go back. BC is a tangent, okay? So we know that BC is a tangent. We know that AC is a chord, all right? So it will be equals to that angle there. So we've got X. We're not there yet. We need to find E1, all right? But now there is something that they've given us. We know that AE, it's equals to EF. So you've got an isosceles triangle there.
Yes.
Is that right?
Yes.
So in other words, we have this whole angle here as X. The base
These
angle is
angles of-
equal.
of
Okay?
this, yes.
Sure. So now we've got F is X and A is also X. Now, how can we find that E1 now?
We can consider triangle AEF,
Consider triangle AEF.
and we know two angles, base angles with equals to X, so we can find the other angle at E
Okay.
on the straight line with, the angle AEF.
Okay. Now, guys, Ndife is saying, okay, you've got that triangle, all right? So this is triangle AEF. He's completing the triangle, work out what this angle is. Okay, that's another option.
Yes.
You get that angle as 180 degrees minus
Minus
2x, right? If you add all those angles. And then the next part that he's going to do is to get that angle by saying E1 plus that one, 180 minus 2x, which gives us 2x.
Yes.
So he's got this one as 2x, okay? But the other way of looking at it is that this angle is an exterior angle of this triangle. So if you add the two, the x and the x, so therefore E1 is E1, it's equals to 2x. So whichever way you look at it, at the end of the day, you'll get the same thing. All right, guys, I'm just going to give you 2.2, right? Okay? I don't know if you can go.
You can.
Just finish this
Okay.
one. All right. So now the next part, they're asking you to express O1 in terms of x, right? O1, okay, there is O1 here. We need to express O1 in terms of x. Guys, we need to open our eyes. Ndife, please help us.
Yes. Now, because that is the angle at center, and we know the angle at the circumference subtended by the same chord. So O1 is going to be twice the angle at the circumference subtended by the same chord.
Thank you very much. Remember that theorem, guys. You've got an angle at the center, all right? So it's subtended by AC, okay? And AC, again, subtends that angle there at the top there, which is your F. So we know that O1 is twice F, all right? Angle at the center is twice the angle of the circumference. So, and 2 by
X.
x, so we know that f is x, so therefore O1 is 2x, all right? So now that's done. And then 2.3, now they're asking us why is OACE a cyclic quadrilateral, right? Why is AOEC a cyclic quadrilateral? Why is it that we can draw a circle around those points? Okay?
Yeah, I think it's going to be because we found that angle O1 equals to 2x and E1 equals to 2x.
Thank you very much. That's correct. Right. O1 is 2x and E1 is 2x. So they both subtended by AC. So therefore, it can be a cyclic quad. Okay. Right, guys. That concludes our question 2. I think we can just take a break and then we continue.
All right. Mindset is just to remind you, don't forget to enter the SA Water Games. All you need to do is go to www.watergame.co.za, and there you'll have a chance to register and start playing the game. What it does is that it wants to see what you think of water issues in South Africa. There's a lot of turns, and it's a turn-based game, and there's a lot of levels in the game as well. So you have a chance to play a lot of times to beat your previous scores, and there are a lot of prizes to be won, guys. So visit www.watergame.co.za, learn more about water conservation, and just see what you think about water issues in South Africa. So with that said, let's take a very quick break, and we'll see you straight after this. Welcome back from that break, guys. You're still with Luni, Sihle, and Ndife, who's the genius in studio. So with that said, Sihle.
Okay, we continue. Ndife, you ready?
Yes, I'm ready.
Okay, moving on. Okay, right, you've got your question 3 now. PQ is a diameter, okay? All right, so we've got PQ as our diameter, all right, and MPB, right, MPB, okay? Now, it's 122 degrees, so the whole angle here is 122 degrees. And MT is a tangent. Where is MT? Okay, there is MT is a tangent, right? Now we need to work out the magnitude of Q. So we need to find this angle here, right? You're gonna help us? Or not yet?
I'm still
okay.
busy.
All right. Ndife is still busy. Okay, let's just work together here. You've got that 122, right?
Yes.
And we know that this is a diameter, and it subtends that angle there. Okay, so it means that we've got a 90 there. That's right. Okay, and now another thing is you've got a center here. Okay, this would be your radius. Radius is diameter, and the diameter is perpendicular to the tangent. It's perpendicular to the
90.
tangent. And guys, now watch. We can find this angle here,
Yes.
P2. How can we find P2?
We're going to say 122 minus 90.
122 minus 90, because the whole angle there is 122, and we've got a 90 here. To complete that, we can find that P2. So what is 122 degrees minus 90?
32 degrees.
That's 32 degrees, okay? So we've got 32 degrees now. It is easy to find that Q. Ndife?
Yes.
What is Q now?
For Q, we're going to say you're going to complete this triangle QPB by saying 180 minus 90 minus 32.
Minus 90, and then we get that Q. I'm just writing what you're giving us. So in simple terms, it's got P, B, and Q. Add all those, you get 180 degrees. So therefore, your Q will be equals to?
58 degrees.
So we've got 58 degrees, okay? I think I agree with you. So it is 58 degrees, our Q there. Now, the next one, we need to find A. Where is A? There is A, right? Any idea?
Yeah, if we can check our quadrilateral APQB is a cyclic quad.
Okay, so APBQ, this is a cyclic quad, and there's another property that we can just work out.
Yeah, we know that Q is supplementing A because they are opposite angles of a cyclic quad.
Opposite angles of a cyclic quad. So you've got A plus Q equals to 180 degrees, opposite angles of a cyclic quad. But we do have the magnitude of Q, so A plus 58 gives us 180 degrees, and now it's easy to work out what your A is. So what's the value of A?
122.
It's 122 degrees. So A equals to 122 degrees. I hope you all working together like I am doing with Dife at home. All right, so that concludes our question 3. Right. Now, question 4. In the figure, triangle ABC, all right? So you've got ABC is inscribed in a circle, okay? So in this, you've got BAC. It's in that circle, okay? Now, and PC equals to PQ, right? So it is given that PQ, it's equals to PC, right? Let's do that. Okay, and then PC is a tangent at C. Where is PC? Okay, there is PC, right? It is a tangent at C. Okay, now to cycle through A, B, and C. Now we need to prove that ACQP is a cyclic quad, right? We need to prove that ACQP is a cyclic quad. Can we draw a circle around those 4 points? Right. What is it that we know? What's given to us? One, that PCT is a tangent. Okay? Right?
Yes.
Now, if we say, now let's work together with this one. Okay, if we say, okay, let C4 be x. Okay? Now, if this is x, C4, which other angle is equals to x?
A1.
A1 will be equals to x because this is a tangent, okay? There is your chord, then it will be equals to that angle. That will be x, okay? And then what else can we say here? Now, what, Ndife, are we okay if we're saying C4, it's equals to C1?
Yes.
Okay?
Because they are vertically opposite.
Vertical opposite angles. And then what else can we say? One last thing. Luni is going to help us as well. Oh, not yet, pending. All right, guys, and another thing that they told us is that, now, let's be together here, Ndife. PC, it's equals to PQ, so therefore, this angle here is also x. Why are we saying it's x? You've got, this is an isosceles triangle, right? So now the base angles will be equal. Now, that can conclude our question here, that if this angle is x, and then that angle is also x. So now the exterior angle of a cyclic quad equals to the opposite interior it's equals to the interior opposite angle. So in other words, we can draw a circle. Yo, it looks like a head of someone, right? So this exterior angle will be equals to that. So therefore, ACQP is a cyclic quad. Exterior angle of a cyclic quad equals to the opposite interior angle. Okay, I hope that helps. Now, we've got the next question, right? Question 5. In the diagram below, diameter AB is produced to C. Now we need to get where diameter AB is, okay? So you've got your diameter AB produced to C, all right? Now, there is a theorem again that talks of a diameter, right?
Yes.
Which one is that?
The one that say a diameter subtends 90 degrees.
Okay, an angle subtended by a diameter is 90 degrees. Okay, CE is a tangent to a circle at E, AE is produced to D and DC. Now, what's happening here? DC, and they're just giving us AC as well. DC. There's DC, there's something missing here. Okay? Just say DC and then AC. DC.
Maybe it was supposed to be an equal sign. I'm not sure.
Okay, but impossible. We'll check later. Okay, can we? Okay, let's see with the questions here. Prove the following. Prove that BEDC is a cyclic quad. Okay, prove that BEDC is a cyclic quad. How can we prove that BCDE is a cyclic quad? Now, guys, very important. Started from that, the given information. They said here, there's a diameter AB, all right? And we agreed, me and Dife and you guys, that an angle subtended by the diameter is 90 degrees. So it is 90 here, okay? Right? Now, if we have that, okay, we're saying E3, it's equal to 90 degrees, okay? Angles in the semicircle, right? And again, C2, it's equal to 90 degrees, okay? And the reason here, it is given. We found it there in that diagram, okay? So it is given. And if you look at this, if I draw a circle around here, can you see that there's a 90 here, there's a 90 there, there's an exterior angle of a cyclic quad equals to the opposite interior, then we conclude by saying, therefore, BEDC is a cyclic quad opposite interior angles of a cyclic, okay, an exterior angle of a cyclic quad equals to the opposite interior, okay? Right, now, so we've covered 5.1, right? Now, the next question, guys, we need to show that D1 equals to A. We need to prove that this, right, it's equals to that. Help us.
Okay, I'm still kind of busy now, trying to figure that out.
Let me kind of, what did you say? Okay, let me kind of assist you. All right, let's work together here. Let us say here, let that angle, because we're told that this is a tangent, okay? So that CE is a tangent. If we can make this angle, is it going to help us? We need to work out this, okay? If we work out this, it will give us that angle, all right? Or if we work out that, it will give us this angle. Okay, yeah. So we need to come from that side. If this is a tangent, okay, that is your tangent. If we let this one, what is this angle again? This is E1, that is E2, ne?
Yes.
Okay, so we let E2 be X, all right? If this angle is X, that is X. Now, do you agree that this angle will be equal to that angle?
Yes.
Because there's a tangent here, and then there's a chord, so it will be equal to that angle, right?
Tan chord theorem.
Tan chord theorem, right? And then again, we have proved that BCDE is a cyclic quad. And if you look at your BC, it subtends that angle, okay? And then BC again subtends this angle, right? So in other words, if this is X, then this one is also
X.
It's also X.
Yes.
And then you conclude by saying, therefore, D1, it's equals to A, right? Now, if you look at the reasons there, okay? Your angle E2, right? E2 it's equals to D1. All right? And subtended by, both subtended by,
Same chord.
by the same chord, and the chord is BC,
BC.
by BC. All right? And another thing is that we know that E2 is also equals to, it's equals to A. So E2, it's equals to A. And you said, Ndife, this is a tan chord.
Chord theorem,
Okay?
yes.
Tan chord theorem. All right? Now, if these two, D1, it's equals to E2, and A, it's equals to E2, we conclude by saying, therefore, A, it's equals to D1. So you've proved that A is equals to D1. Okay. Now, the next question is to prove that CE, it's equals to CD. Okay? Now, I must have to erase some of the things here. Okay. We need to prove that CE, all right, there is CE, that CE, it's equals to CD. All right? Now, how can you prove that CE, it's equals to CD?
I think we need to prove that angle at D is equal to the angle at E. That proves that triangle is a cyclic quad.
Thank you very much.
It's an isosceles triangle, sorry.
Okay, if we can get this angle equals to the whole angle there,
Yes.
then we can conclude that EC is equals to CD.
Yes.
All right? Now, one thing that we know is that this is a tangent, so that angle, right, E4, if we make this Y, that angle will be equal to that one. Okay? Is it helping us?
Yes.
Right? And then because we know that this is a cyclic quad, right? And this is an exterior angle of a cyclic quad. It will be equal to the whole angle there, then this will be your Y.
Also.
And your last bit of information is that, look at this. This and that. This angle E4 will be equals to your E1. So it means that this is also Y, okay? E1 will be equals to your E4, vertical opposite, right? So now if that is Y and this is also Y, it concludes that ECD is isosceles, okay? ECD is isosceles, so therefore your CE is equals to CD. So CE will be equals to your CD. Your base angles are equal, right? Luni, I think we can just take a break before we move on to the next question.
All right. Before we take a break, Mindsetters, quick shout out to Smanga Sitole, Blessing Mkonazi, Chibulebule Mbuwe. Wow. Nointle.
Wow.
That name. Bali, Tero, Mukove, Katleho, Tsaki. I want to send all these shout outs. Tsarocha. And then Tsarocha is asking if you could say hi to Poteho Makanyane as well. And Tabete, shout out, I enjoy and love mathematics. I would like the challenge question. The challenge question is on the page. Mindsetter and Sanele. Thank you so much, Mindsetters, for tuning in. Let us take a very quick break and we'll see you straight after this. Welcome back, Mindsetters, from that break. Ndifa has some fans on our Facebook page. We've got some questions for you. So Sanele is asking you, Luni, please ask Mr. Genius, what did he do to remember all those theorems?
What I can just tell you, Mindsetters, there at home, is that what you need to do is to read all the theorems, understand them, and do the question all over and keep on practicing day and night. You will definitely remember them.
And then there's a special shout out for you from No and Claire. She's saying a big shout out to Ndifa at the studio. He's definitely a mindsetter. You see, you're getting fans.
Yeah, I can see.
'Cause
I'm
you're a
doing very
genius.
good.
All right, Sihle.
Famous Ndife. Right, Luni, can you please help me? Have they answered the challenge question?
Yes, they have. I'll look now for you.
Ndife, please sit and do that.
Okay, we've got a few,
challenge.
Okay.
a few answers. So Andile says 13.74.
13.74.
And then Sanele says PS is 18.79.
18.79.
And then Sizwe says PS is 15.4.
15.4.
Yes, those are all that we
The
have.
answers. And we
Yes.
need to see if they are correct or close to being correct. Okay. Nife, what's your answer? Or are you still working on it?
I'm still working on it.
Okay. All right. Now, guys, we've got those two circles, right? Smaller one and a bigger one. Okay, we've got the centered at O. So you've got your O there. And then one radius for a smaller one is 5 centimeters. So you've got a 5 there. Okay. And then the other one, it's 8,5. So that distance there is 8,5. All right. And QR is 6 centimeters. Now remember your theorem 1. Okay. If the whole distance here is 6, right? So it means that we've got a 3 there and a 3 there. Am I right, Dife?
Yes, yes.
Okay. Now, guys, with this information here, we need to, at the end of the day, work out the distance from P through Q, T, R, and S. So we need to get PS, right? Now, what do we have? We've got the 5, we've got the 3, so it is easy for us to work out the OT, right? Because this is 90 degrees. Okay? Now, how can you find OT? Pythagoras theorem, right?
Yes.
Now, so we've got OT squared plus QT squared, it's equals to OQ squared. Now, what do we have? We're looking for the OT, so OT squared plus QT is 3 squared equals to OQ is 5 squared. Then OT squared will be 25 minus 9. And then we get OT squared is 16. Therefore, OT is 4. Now, guys, we've got that as 4. All right? Now, if we have that side and we've got the hypotenuse there, it looks like it's now easy to work out this side as well. Am I right?
Yes.
Again, Pythagoras theorem.
theorem.
So you're going to help me here, Ndife. We know that OT squared plus ST squared will be equals to OS
Yes.
squared. All right? Now, OT, we just worked out what OT is. This is a 4. So we've got 4 squared plus ST squared. Oh, we do know ST, isn't it? No, that's the one that
That's
we're
the
looking
one that
for.
we're looking for.
All right? So we're looking for ST equals to OS squared. That's 8,5 all squared. Now, ST squared will be 8,5 all squared minus 16. Now, please help us, Nife, with your calculator. ST will be the square root of 8,5 squared minus 16.
56.25.
It's 56.25.
25.
So we've got 56.25, but that is still squared.
Yes.
And then square root that, so ST will be the square root of 56.25.
7.5.
We get 7.5. Now, guys, now watch. We have that 7.5 centimeters. Now, can you help us now, Ndife? How can we get the whole distance, PS?
Because we know that 7.5, and we know that from T to R is equals to 3. So we can first have to find SR. If SR by saying 7.5 minus 3.
Okay, then we get that 4.5. But
Yeah.
the quicker one is that if you look at this, you look at this circle here, all right? Now I'm going to draw a chord, right? And then call it PS, right? and then here, there is OT. We know that this is 7,5. This is perpendicular to that.
Yes.
Then, so it goes without saying that this is also 7,5.
Yes.
Right? So from your theorem 1. So therefore, PS will be equal to 7,5 plus 7,5, which gives us 15 centimeters at the end of the day. So our challenge question, our final answer for our challenge question is 15 centimeters. Anyone who got that as just 15, not point something?
Sanela just said she corrected herself. She got 15 as well.
She corrected herself.
Yes.
It is just 15 centimeters. So that answers our
Andile also
challenge.
got 15. Mutenda also got 15.
Now they're
Simpiwe
getting 15 because
also
we
got
just
15.
these
Kamukele
kids.
also got 15. John got 15. Mfundo got 15. Yes, they got 15. What if they were doing it while you were doing it but not looking, you see, Nje?
Okay,
They
all
got
right.
15
No,
before
now
you
I
got
get
15.
it. All right. So now, guys, thank you very much for the challenge question. All right. The final answer is 15. Right. We move on to question 6. Right. Question 6. You've got ABCD is a cyclic quad with AD produced to E. Right. So you've got your AD produced to that guy E, and DE equals to DC. DE, it's equal to DC, right? And C and D are joined, and DB is the angle bisector of ABC. Very important, okay? Now, your DB, where's DB? You've got D, B, right? And we're told that it is an angle bisector, so it will be bisecting those two angles. So at the end of the day, your D1, your B1 is equals to B2, all right? Now, let B1 be X, okay? Right, let B1 be X. Now, quickly, if that is X, then this one is also X, because we are told that this is your DB is an angle bisector of ABC.
Yes.
Okay?
Yes.
So you've got X there. Right?
Yes.
Now, they're asking us to prove that C1 is equals to B2. All right? C1 is equals to B2.
Yeah.
Right? Now, that's a straightforward one.
Yes. Already
All right.
proven.
Okay, because we've got AD, right? This is AD. That subtends this angle, which is X. And then AD again, it subtends that
C2.
angle. So this one is also X,
Yes.
right? So we can say B1, it's equals to X, equals to C1, subtended by the same chord, which is subtended by AD,
AD.
all right? Now, and then B1 is also equals to B2, all right? And we are told that it is DB is the angle bisector of ABC, so this one it's also equals to X. And then we conclude by saying, therefore, C1 is equals to B2. We're done with that one. Okay, now let's look at the next problem. Prove that AD equals to DC. Where is that? AD. Okay, we need to prove that AD it's equals to DC. Right? What do you need to know here?
I think here we need to know that equal cos subtends equal angles.
Okay? Right. Now, at the end of the day, they want us to show that this it's equals to that. Am I right?
Yes.
AD equals to DC. So if you can get this angle equals to that angle, then we can conclude by saying AD it's equals to DC. Is that possible?
Yes.
Thank you. Thinking. Yes, that's possible, because if we look at DC, it subtends that angle.
And
It also subtends B2. So this angle here is also X,
Yes.
right? So A1 is also X, subtended by the same chord DC. Okay, and again, remember we said this is this is x proven above. So if this and that are equal, so C1 equals to A1, both equals to x. So we conclude by saying, therefore, AD is equals to DC, base angles are equal, right? So we've got that isosceles triangle. Now, Ndife, find CDE in terms of x. Find CD.
CDE.
Oh, okay. No, my bad. Where is C? CDE. So we're looking for this angle.
We all can see that CDE is the exterior angle of a cyclic quad. So it's going to equal to the whole angle at B.
The whole angle at B, right? So you've got this, that, that, so it's equal to that.
Yes.
Okay, which is 2x.
2x.
Okay, so you've got, you can look at it in different ways, right? So it's looking at the exterior angle of a cyclic quad, or look at this triangle here, okay? It's outside that triangle, and then you've got two opposite interior angles, all right? The exterior angle of a triangle equals to the sum of the two opposite interior angles, which is what you did in grade 8. So this will be your 2x. Or someone else can just complete this triangle here. This is x by x plus that unknown equals 180. Then you get that 180 minus 2x, and then angles on a straight line. So your d will be your 2x. Okay, right. So that is done with question 6. Now, question 7, if we still have time. Please look at question 7. I'm working with you on question 7. Now, let's just read here. In the figure below, P, A, R, C, Q, U, and B. Where are those guys? That's P, A, R, C, Q, B. Are points in the circumference of a circle, right? Give a reason why P plus C2 equals 180. Help us say here. P plus C2 equals 180.
Opposite angles of a cyclic quad.
P plus C2. Now, can you see that you can draw a circle around those points, right? If you add the 2C2 plus P equals 180 opposite angles of a cyclic quad. Okay, now let's move on to the next question. This is opposite angles of a cyclic quad, right? Now, prove that P plus Q plus R equals to 360. Right, P, where is P? You've got a P here, right? And we are told that if you add it to that, you get 180 degrees, opposite angles of a cyclic quad. So you've got P plus C2 equals 180 degrees, opposite same reason, okay? So therefore, P is 180 degrees minus C2. Is that right?
Yes.
That's the first part. Now we go and look for that Q, right? So Q will be equals to what? Q, this Q?
Q is opposite to
A2.
To A2.
So therefore, we say Q plus A2
equals
is equals to 180 degrees. Then Q will be your 180 degrees minus A2, right? So that's done with that. Now we're looking for R. So R will be opposite which angle? So R, there is R, it's opposite that angle, B2. So R plus B2, it's equals to 180 degrees. Therefore, R is 180 minus B2. Okay. Now, guys, quickly, we then go back. P plus Q plus R. That's what we're looking for. It's going to be equals to the first bit. It's P is 180 minus C2, Q is 180 minus A2, and R is 180 minus B2. So it's going to be 180 degrees minus the first one is C2 minus C2 plus 180 degrees minus A2 plus 180 degrees minus B2. Okay? Now, please help us here. You've got 180, 180, 180. Those three are like terms. What is 180 plus 180 plus 180?
360.
Chief, no. 180 plus 180 is 360.
360, oh.
Plus 180,
Is
that's 540.
540.
That's 540. Minus
Oh.
C2 minus A2 minus B2. Okay? So we've got 540 degrees minus. Factor out the negative one, so C2 plus A2 plus B2. Okay? Now, guys, where is the C2, the A2, and the B2? If we look at this triangle here, there is A2, there is B2, there is C2. Can you see that this is a triangle? You've got your A2, C2, and B2. If you add all of those, you get 180 degrees. So this is 540 degrees minus 180, right? What is 540 minus 180?
360.
360. So you've got 360. So therefore, P plus Q plus R, therefore P plus Q plus R equals to 360. I think we just...
Done.
It's done.
Yeah, we're finished.
Okay. All right, guys, thank you very much for listening. Thank you, Prazo.
Thank you, Cyclic. Thank you so much, Ndife. Do you want to send any shout-outs to your friends, your family?
Yeah, I'll send a shout out to my friend at school, Leonard Mdluli and Martha, and other ones. And at home, I'll shout out to my cousin Rufuno Nejarata and my other cousin Furfero.
And your school, your entire school.
Yeah, even everyone who knows me.
All right, thank you so much,
know
Ndife, for
it.
tuning in, for joining us, not tuning in, for joining us and for being such a genius. You're so smart.
I know.
We appreciate you. Mindsetters at home, thank you so much for tuning in. We love you very much and we wish you all the best for your studies. Until next time, we'll see you then. Goodbye from us.